So NICTA stands for National ICT Australia. So we are Australia's largest government-funded research organisation, and we specialise in building digital technology and applying that digital technology to all sorts of industries. Those industries can be large enterprises, typical software that you would expect. Those industries can be health. We also work in the resources sector, defence sector, and also across transport and logistics. So it's a very broad charter, but the central core is always to use digital technologies, computers, to actually do things in a more productive manner that makes it more pleasurable for humans and gives a real impact. So that's our organisation's quest. We're about 700 people. We have labs across Australia, and we have a really strong industry engagement program and basically a charter to use research to make a big difference. So my name is Dean Economou. My title is Technology Strategist, and my role is really to match market need and anticipate market need and match that with what researchers and technologists are currently researching and what they might research. So my job is to make sure that maybe in 3 to 5 to 7 years' time, what the research is providing is meeting what the market needs, okay? And so that's an extremely interesting job where you're a little bit of a futurist, you're something of a business person, but at the same time you're really in touch with the technology that's emerging. So I find that to be an extremely interesting role, especially in such a large organisation as mine, which has so many different areas it applies its research. So we have projects from our software systems research group. That group is very concerned with trustworthy software and dependability, and one of the outcomes of that is basically some tools which allow you, if you're running on, say, Amazon Web Services, to actually have a backup across a different Amazon Web Services region. So Amazon has got data centers on the west coast of the US, it's got one in Singapore, the east coast of the US, and if one of those centers were to go down and you're running your company's software, like Salesforce or something, actually there's no way to do an automatic disaster recovery. So we have software which will allow you, if you're running off the west coast of the US, to have another instance of your company's software running on, say, the east coast of the US, and if the west coast stops for some reason, some natural disaster, whatever it could be, you can run your business after 30 seconds or a minute from the east coast. So that's one kind of area that I think is very exciting. The other area that's exciting, these days people talk a lot about big data. Probably a better name for it is big analytics. And we've gone from an era where very large companies with a lot of money, a lot of in-house hardware and expertise, perhaps hired from a large consulting company, could get a lot of business insight. It's very expensive. Now what we're seeing is more sophisticated techniques where smaller numbers of people with not quite so sophisticated computer science and mathematical skills using new software can actually get that analytic insight at a much lower price and making it much more accessible. So I think that's a really exciting trend. So analytics is going to move just from large banks to much smaller organisations, I think. So that's going to be a very important trend. The other projects we're working on are actually in the physical world. So if you're looking at transport systems, all of us who live in a large city know how painful it is to have congestion and gridlock and all these things, and this actually constrains economic activity. So there's been for a few years a big push to introduce technology into our transport systems to make them intelligent. Some cities like London and Sydney actually developed some technology a long time ago to help synchronise the traffic lights, etc. We're now moving to an era where the cars are becoming intelligent and there's an interaction between the road system and the cars. And with the new kind of optimization mathematics we have at the moment, we are now looking at being able to do a much better job than ever before. The other thing now is when you're running logistics networks, the world of optimization, which is the science of making things better, is now allowing us to make improvements of 20, 30, 40% in the running costs and profitability of something like a large fleet of trucks. And that's all down to intelligent computation and the ability to understand where your whole fleet is these days with GPS units in mobile phones, etc. So I think those areas are the ones that are really colourful for me at the moment and interesting. And there's actually one other one I thought of. There's a technology called machine learning, and machine learning is a kind of artificial intelligence which basically takes patterns, so data patterns over time, and if you show it particular patterns, it can then predict a new pattern when it sees it. So for example, it could be that you watch a certain type of television program. If you have something that's learning about this, it can then make recommendations. So you will have seen that sort of thing on Amazon. But that technology is actually much more general and more powerful. And if you've got an Android phone and you have Google Now, you'll see it's actually trying to notice what your life is like and make predictions. We can also use that to do things like predicting where you need to repair a water pipe, or predicting where there will be a traffic incident, or in fact predicting that there's actually going to be some interesting climate activity in a new way. So it's a very powerful technology which I think will see increasingly automate a lot of processes. So another area which is extremely interesting applies especially if you're running a very large private or public organisation. Governments make a lot of regulations to make sure that business is done well and everything is fair. Unfortunately, sometimes those regulations are extremely complicated, and a large organisation, be it government or be it private sector, spends a lot of time and energy trying to comply to the regulations. Government spends a lot of time trying to write good regulations, and the process is at the moment largely manual and extremely expensive. So there is now special kinds of logic which are quite good at interpreting natural language, and special kinds of logic which are extremely good at expressing the kind of intent that is in a regulation. And also, if you can express your business processes in the right kind of logical language, you can then automatically check whether you're complying with the regulations. So we're entering an era where if we're prepared to put the effort into writing the regulations in a way which a machine can understand, first of all, we can see if the regulations are consistent with themselves and whether they're repetitive, and improve the quality of the regulation. And secondly, you as a business or a government agency attempting to comply can do this automatically. So when the regulation changes, you can very quickly check if you comply. So the audit is an automatic process. Or if you change a business process, you can check if that new business process complies with the regulations. And at least in the Australian context, we estimate compliance costs 4% of GDP, which is a very large amount. In Australia, that's $50–60 billion a year, and a lot of that we think can be automated if you make the upfront investment. The relentless push of mobile, it will take all before it. I think basically every IT system at the moment is adapting to the fact that mobile is becoming the premier way that humans are actually interfacing their computation and doing their interactions. So we're moving into a world where the mobile device is one for consuming content, maybe producing a little bit with photos and stuff like that, but really laptops are for people who produce content. So I think we live in very interesting times, and we're only a little way into that particular megatrend. The other one is, I think, this area of analytics and getting machines to understand things, this insight. As I mentioned before, I think this will become commoditized, productized, and become much more accessible for smaller companies and people who are not necessarily expert in the field of data science. And this is very important. The US estimates, I think McKinsey did a report, there's a shortage of 300,000 data scientists in the US. So any young people out there thinking of studying, you should learn data science, which basically means know about mathematics and know how to code, right? The other interesting trend, I think, is around how we apply IT to the physical world. This is very important. So we've got two things happening. In the so-called digital economy, the world of iTunes and content and software, you can have a lot of economic growth by producing products which actually have no carbon footprint to speak of, very small carbon footprint, and very large economic growth. You do still need to drive around, you do still need to transport things. So when it comes to using the physical resources of the world, we have to be as careful as possible. We need to minimize the use of that. First of all, because it improves your profit if you're spending less money, but secondly, it's good for the environment. You only move things when you need to. So there's a whole science around optimizing transport, optimizing logistics, which has become extremely powerful lately, because in the last 10 years, the power of our computers and the kind of mathematics we can implement on them means that the systems we can optimize, instead of just being a relatively small part of the road system, you can now think of optimizing an entire city. Or in one case we're doing in Sydney, we're looking at how the ships come in and out of the port, how the rail network and the truck network comes in and out of the port, how that then feeds into the rail and road network in Sydney, how that interacts with the passenger traffic, how it goes out to the warehouses in the suburbs, and so you're looking at a supply chain that goes from the ship to the shop. Now, 10 or 20 years ago, you could not model that in a reasonable amount of time. So I think this is going to be an incredibly exciting era where we basically minimise our use of resources for both economic and social and environmental reasons, and the power of IT to do that is something that drives it.